Hear my voice? Clear? Okay, so today will be the last tutorials on tutorial 9. So let's start the tutorial sessions today. So on tutorial 9, questions 1, they ask you about the functions of EU and BIU. Okay, so the EU is the execution unit. Okay. Is the one which executes the instructions fetched by the processor. And the BIU is the one who access the memory to get the instructions. Okay, there's two main parts. One is fetch, one is execute unit. For you to run the instructions. Okay, then we go to questions 2. Why does pipelining improve your performance? So they're able to improve by divide the instructions into stages. Then they overlap the stages to reduce the time compared to a sequential instruction execution. This is the thing we discussed in the lectures. They break them into different stages so they can fully utilize all the resources inside your computer at the same time. Okay. They want to make sure there's no resources will be as rest mode or in doing nothing. So that's why they break the instruction into stages. Then at each cycles, all the resources are working. And they ask about the pipeline latency. So the pipeline latency is the time required for execution of a single operations. We will see how we calculate the pipeline latency in the subsequent questions. Okay, basically it's the amount of time required to execute a single operations. Number 4. So in here there's 6 stages and 4 instructions, right? Then they want to divide it to 2 only, right? The 2 stages, and they want to compare to sequential pipeline. This will the thing you need to draw. If they ask you to draw, you need to draw in this form. Okay, the time and the instructions numbers. First instruction, second, third, and fourth. Then the cycle, first 2, second, third, fourth, and fifth cycle. So they divide every cycle into every instruction into 2 stages, right? They can overlap them to finish in a 5 cycle. So how many cycles you need if it's in a pipeline? If we assume say is ideal, we can break them into 2. They need 2 cycles. If we didn't break one instruction, need 2 cycles. So how many cycles you need if it is in a pipeline sequential operations? So you need 8 cycles if it's in pipeline. Okay, one instruction equal to 2 cycles, so 4 is 8. Okay, so this is the formulas you use to calculate your pipeline and pipeline, right? 2 stages, 4 instructions, so you need 8 R, right? R is the cycle time, right? And this is the pipeline using this formula. The K is 2, N is 4, you get 5R. So if you want to get the speed up, you're just using the sequential times divided by the pipeline. So the R can be cancelled, so you get 8/5. Yeah, so this is a speed up if using 2 stages compared to pipeline. Okay. So far, any questions? No, then I proceed. Questions 5, they ask you to do the same thing, 600 instructions with 6 stages pipeline. So what is the time required by pipeline? Your answers for the pipeline one? How many R? 605. Using the formula, you can get 605. Okay. Then non-pipeline is a 3600. Okay. So the speed up you get is a 5.95. Okay. So you can see if more instructions, then you will get more speed up from the pipelining. Okay, remember the formula K plus N minus 1. Okay, this is a big bracket. Bracket, you need times R. Number 6. They're given an pipeline processor with 10 nanosecond cycle time and a pipeline latch with 0.5 nanosecond. What are the cycle time pipeline version of the processor with 2 forces? So what are the cycle time for 2 stages? The cycle time for 2 stages is 5.5 nanosecond. Right, you divide them. This is the total cycle time required for pipeline instruction. So one instruction they need 10 nanosecond. One instruction requires 10 nanosecond. So you break them into 2 just using 10/2. We get 5. Okay. And they told you there's a pipeline latch. Okay, with 0.5 nanosecond. So you're just using 5 plus 0.5. You will get 5.5 nanosecond per cycle. Okay. You do the same to the 4, 8, and 16. So if it's 4, you're just using 10 divided by 4, 10 plus 0.5, right? Using the same formula, just changing this one with 2, 4, 8, and 16. Okay, then you'll get your answers. Okay, without pipeline, the time is 10 nanosecond. When a pipeline is applied, assume the time is divided equally into each stages. Therefore, the pipeline is using these formulas. So this is the one we use just now. Okay, CT on pipeline is 10 nanosecond. Latch latency 0.5. Number of stages 2, 4, 8, and 16. Then for 4, you will get 3. For 8, you will get 1.75. 16, you get 1.125. So the latency is a single of instructions. You will get 11, right? 2 stages, you need 2 times 2. So it's 11. 4 stages, you need 2 times 4, right? 3 times 4. Okay, this one multiplied by this one, and for 8, you will get 14. The latency. 16, you will get 18 nanosecond. So mean one instructions you need this amount of time, right? So from here you can see if you break them into time, it's actually you require more time as compared to single instructions. If you break them into more stages, right? If 2, 11, this is 10 only. But if it's 16, then you will go to 18 nanosecond. But this is 10 nanosecond only on pipeline. But if you doing pipeline, you are able to stack them, overlap the instructions. So at the end, you will faster as compared to on pipeline. Okay. X and must we assume the value of which formulas? Oh, this one. Sorry, the previous questions. The R not necessary. Not necessary. You can just put R in your exam if they ask these questions. Okay, you can just put R in your exam. Okay. Okay, so for question 6, understand how they get the pipeline cycle time. Okay, 2 different things. Cycle time is every stage, the time required by every stages, and the latency is the whole overall time required when you put all the stages together. And they made some assumptions that they can divide them into even. Okay, if in the cases we cannot break them into even, so let's say I have a fetch, decode and execute. Okay, I have 3 stages, and my fetch maybe need 2 nanosecond. My decode maybe need 5 nanosecond. My execute need say this is 4, 6, 2, 4, 6. So what should be my cycle if I'm in this condition? I break them into 3, then I found fetch need 2, decode 4, execute need 6. So what should be the cycle time? I should choose the highest. I should using the 6. I cannot use the lowest. Okay, if you use 2 only, then the execute will not have enough time to finish because execute needs 6 nanosecond. Okay, clear? If the time is not is divided in uneven form, you need to select the maximum time required to be the cycle time for every stages. Okay. Calculate latency for question 6. Latency for question. Latency is just this. Okay, so let's say it's 2 stages. Fetch and execute. Right. We do the example for this one. So the assume is evenly. So one stage is equal to 5.5 nanosecond. The second stage also 5.5 nanosecond. So the latency is basically just add up these 2 only. Right, equals to 11. The latency is the time required to finish one instruction. Clear? So let's say you break them into 4 stages: fetch, code, execute, and store. Let's say they store back the result. So the time required is 3, right? In the formulas. You break them into 4, 10 nanosecond. You break them into 4, so each cycle need is a 2.5. But they said there's a latch latency, right? There's a latch latency, pipeline latch 0.5. So you need to add 0.5, so each stage will become 3 nanosecond. So this is 3 also. 3 also. So in total, one instruction you will need 12 nanosecond. Okay, this is how they get that. Any other questions on this one, pipeline? This is important. I need to clear about this one, how to using the pipeline calculation. So if no questions, we will go to the next. List and briefly explain the various ways in instruction pipeline deal with conditional branch. So this is the final questions. So these are all the ways for us to overcome the pipeline hazards, okay? The branch hazards. The first one is multiple streams, prefetch branch target, loop buffer, branch predictions, and also delay branch. Okay. So you need to have a loop buffer inside your processor. So the loop buffer is a place to store the address, or even the branch target address, or even the branch instructions. And whenever you found out there's a similar conditional branch happen, you can check into this loop buffer to see whether this branch target address or the branch target instruction is inside this buffer or not. If it's inside, then you can prefetch the branch target. Okay. Then the second one is a multiple stream. So it means they have a multiple streams to do the same pipeline, so that you can run the both of the instructions. One is a without branch, one is a branch. Okay. Then the fourth one is a branch predictions. You can predict them either be taken or not taken, or based on their types of okay, different types of branch instruction, they will have different predictions, either taken or not taken. The final one is a delay the branch execution. Okay, they rearrange your instruction code so that they push the branch instructions to the later to be executed. This will depend on the compiler, how they do the rearrange of your instructions. So, any other questions? This will be our last tutorial and the last questions. So if you have no questions, then I think that's all for today. And we will see you in the final exam. Final exam is on July, right? Yeah. No more questions regarding this tutorial. If no, I will stop recording. Exam. I also forget the questions. What is the question in exam? I will check back and I will post in the spectrum regarding the chapter you should cover by tomorrow. Okay. I think Dr. Ismail also have another sessions with he doing some revisions. Okay. So if you have any questions want to ask about any part, any chapter, by now we still have half an hour. You can ask me now. Then if we can try to go through. For the exam tips, I think performance we have. Okay. So performance, memory, catch. I think all those memory parts, storage parts, we also have. Yeah, just first chapter, the history. Is it? There's a first chapter performance. We should cover. Draw diagram. I can't remember the exam question actually, but I will go through and we'll post the thing you should focus in the spectrum. Okay. It will a bit different compared to past year because this is the open book task, but the content should be quite the same as past. It won't be exactly the same as past year. The way the questions related to your what you have to be the same as past year. There will not be any questions out of syllabus. Okay, everything you should learn in your tutorial or in your lectures or even your lab. Okay, any other questions? Assembly language, you mean the way to, we won't ask questions like lab test questions. No. Okay. There's no questions related to lab test. Okay. All the exam questions will be related to the one you learned in lectures and tutorials. Okay. And remember to submit all your tutorials, all your tasks, lab tasks, questions, all the assignment given. Okay. We'll evaluate your submissions, then we will give you the continuous assessment mark. And remember to clock in your attendance, especially for those foreign students. You need it for your visa, I think. So any other questions? If no, then I think that's all for today. Okay, so thanks everyone, and see you in your final exam. Yeah. And one last thing. Remember to get your new metric numbers. You need your new metric numbers in your final exam. Okay. So that's all, and see you all. Bye.